Hello everyone, this is Mokaram Ahmed Bathon. So it was a requested video about transistor switching networks math related problem. So it is 4.32 from the Mr. Ballstead book. So let us solve this problem. So determining RB and RC for the transistor inverter figure 4.90, if IC, that is collector current, saturation is 40 milliampere. So let us find out. Given that IC saturation is 10 milliampere, that means 10 into 10 to the power minus 3 ampere. So uh, we know that transistor acts as a switch in the saturation mode and cutoff mode. So saturation mode, we know that in saturation mode we have to keep in mind that in saturation mode the VC is equal to 0 volt. So there is no VCE, cause there is no VCE. Okay, so in saturation mode we can find out the IC saturation by given formula. IC saturation is equal to VCC minus VC divided by RC. So we have to find out the RC, that means collector resistance. Collector resistance would be 10 minus VC, that is 0, and RC, that is IC, that is 10 into 10 to the power minus 3 ampere. So collector resistance is 1 kilo ohm. So we have to determine the RC and RB, for the inverter network. Okay, for the transistor inverter. So in saturation mode, RC we have find out. So let us find out the IB. So we know in the cutoff mode IC is equal to beta times IB. IC is equal to beta times IB, which is the maximum. But in the saturation mode, it is minimum, that is IC is less than beta times IB. So we can see from the equation that IB would be greater than IC divided by beta in the saturation mode. So that is the thing that we have to keep in mind. So let us find out the IB from the equation that we know. So uh, IB would be IB would be IC divided by beta. So beta DC, that is given 250. So IB would be IC, that is given 1 into 10 to the power minus 3, sorry, 10 milliampere, that is 10 into 10 to the power minus 3 ampere, divided by beta is 250. Then we would find out the base current, that is approximately 10 to the power minus 3 into 10 divided by 250, that is 40 microampere. 40 microampere. So the transistor acts as a switch to the for the transistor acting as a switch, it must be greater than 40 ampere. So let us choose a value of base current and determine the base resistance. So let us choose IB is equal to 60 microampere. Okay, so cause we know that in the saturation mode IB must be greater than IC divided by beta. So choosing 60 microampere is greater than 40 microampere. So we can easily choose IB is 60 microampere. So from this circuit we can determine the resistance. Okay, so here is a voltage drop is 0.7 volt, that is VBE. So VBE, so we can determine the base current from the circuit, that is VI minus 0.7 divided by IB is equal to base resistance. So VI is given to us, that is 10 volt. VI is 10 volt. So that is RB is equal to 10 minus 0.7 divided by base current, that have we have chosen 60 microampere, that means 60 into 10 to the power minus 6. Then RB would be 155 kilo ohm. 155 kilo ohm. So let us say our math is done here, but we can further calculate. We can further calculate. Let us choose RB ideal value, that is 155, not 150 kilo ohm. So choosing RB is equal to 150 kilo ohm and RC 1 kilo ohm. So that is the resistance of the transistor acting as a switch or inverter. So so keep in mind that choosing RB 150 kilo ohm, we have to check that the base current is greater than 40 microampere, because we know that the base current is greater than equal to IC divided by beta in saturation region. So let us check. So IB would be 10 minus 0.7 divided by 150. Then we are getting IP, that is 10 minus zero point 0.7, 10 minus zero point 0.7 divided by 150 kilo ohm. So 150 into 10 to the power 3, 150 into 10 to the power 3. So that would be 62 microampere, so which is greater than 40 microampere. So that is 62 microampere. Yeah, so which is easily greater than 40 microampere. So 150 into 10 to the power 3. So here also 155 kilo ohm. Okay, so base current is greater than 40 microampere. Then so we can easily say that our choosing RB is 150 kilo ohm and RC is 1 kilo ohm would easily make the transistor um, run as an inverter or a switch. Thank you very much. That's all for today.